In this assignment, we'll get some practice with free response questions. These are actual questions from previous year's AB Calculus exam, and we will be reviewing areas and volumes. So make sure that you pause the video along the way to do each step on your own calculator. So saying you know how to use your calculator, you also want to make sure that you get lots of practice so that you are quick and confident during those test periods. So in this problem, we are going to put y1 as function f of x and y2 function g of x. A couple notes: make sure you use the pi value key. Do not round to the value of pi. And make sure for this opposite of x that you use this opposite or negative key, never the subtraction key. And as soon as you see a trig function, it is worth it to double check one more time. Go to the mode menu always and double check that you are in radian mode, not degrees. All right, then our next process here, let me get out of that menu. The next thing we want to make sure that we do is to set a good window size. And you don't need to be really precise about the window, but you know a lot about this function. You know that the amplitude of this sine wave is 1, and it's raised up 1/4 of a unit. So the highest y coordinate you would need here would be a 1 1/4. And we know that period of sine is 2 pi divided by b. So 2 pi divided by pi. We know that the entire sine wave has a period of 2. So if we want to set a window here, we don't need to have a very large scale. So zoom standard would be pretty tight. So I think that you want to zoom in, and I picked a scale from -1 to 2 on both the x and the y axis. You could choose something different, but you want to make sure that you picked a reasonable size window. So you can see that I haven't zoomed in as much as they have on the test paper, but I can still see quadrant 1 intersections pretty clearly. So we're going to find this region R and this region S. So I need to know, I can see that these x coordinates start at 0, so I want to know the x coordinate of this intersection point and the x coordinate of this intersection point. So if you need a quick review, we use function f5. Choice 5 is to find the intersection, so you can hit the 5 key. And it's going to ask 4 questions. We only have 2 functions I only have 2 functions in the y editor. So it's asking, is y1 your first curve of interest? So I'm going to hit enter to say yes. Is y2 the second curve you're interested in? So I'll hit enter to say yes. And then I have to move the cursor to the left side, a lower bound of the intersection point, and hit enter, and then use the right arrow to get to the right side, an upper bound. So then we know oops, and evidently I cleared that right away. Let me try that one more time. Choice 5, yes, yes. Let's move the cursor to the left side and to the right side, and there we go. So I'll try not to hit another button. So I want to write this down, and remember this early in the problem, do not round to 3 decimal places. Keep extra digits. So we're going to write down these coordinates. Right now, while I have the calculator out, I'm going to immediately find the intersection. You can pause to write that down, but now I'm going to find the other intersection. And so I want to move, so I have a lower bound here and hit enter. And then I want to move to the right side for an upper bound. And this has a nice easy intersection point at 1, as we kind of were expecting perhaps. All right, so now let's show how you're going to write that on your paper. So you don't want to mark it on the graph if this diagram is in your test booklet. And you'll see how this is going to look as we get closer to our exam day. So you don't want to write anything on that graph because it's not going to be in the region that is graded. So you'll see that there's a rectangle where you are to show all of your work for part A. So we can write here that we found the intersection points. F of x is equal to g of x. That's saying that their y coordinates are equal at x equals, x approximately would be even better, 0.178218, and at x equals 1. And if you don't want to keep writing this value over and over again, you could say let a be equal to this value. So for the rest of the problem then, instead of having to copy all of these digits, you could just use that constant a. So that's not the only way that you could write this, but it is one method here. Another way that you could perhaps say that is you could say F and G intersect at x equals those two values. So either one of those methods would be fine. And now we're looking for the area of R. So now notice that we decided that this x coordinate is our A value, and this x coordinate happened to be 1. So now to find this region R, notice that here we have function g of x is on top. This is function g of x, and in our calculator that was y2, and f of x is on the bottom in this region. So we're doing these Riemann rectangles again. So every integral is adding up Riemann rectangles. So this is region R. So we could write, and you should write this on your paper, from 0 to a, we are taking function g of x, that's the top function, minus function f of x dx. And this is a calculator problem, so you don't have to write any more than that. So now you can go to your calculator and come up with an answer. Don't do more work than you have to. So with our TI-89s, you could do some integrating elsewhere, but I think we might as well go to the home screen. And we're going to do the Shift 7 to get an integral, or remember you can find that in the Calc menu. And what we want to do the integral of is our y2 of x minus our y1 of x, comma, with respect to x, comma, evaluated from 0, comma, to letter A, and I haven't put that in the memory of my calculator, so I want to put 0.178218. And if I would hit something wrong on my calculator here as I'm talking and doing the video, you could certainly adjust that. And then let's always remember to do green diamond enter, because otherwise to come up with the exact answer it might be a little bit slower. So there's our answer for part A. So we're going to round. You could put 0.065, and when you look at the answer key, you might notice that they would accept two different answers, and this is one of those problems that different models of calculators might give you just one digit off. So the test readers have checked very carefully and make sure that they have all of the different calculators covered. All right, so then in part B, we need to do the same thing to find the area of region S, and we already know the intersection there. So it is as simple as saying that we are going from A, we already labeled what that is, to 1, Oh, and I should label this. S is equal to. And now we have function f of x is the top. They swapped places, so now it is function f of x minus function g of x, and then a dx. And it would be nice if you did those in parentheses, but the dx always tells where your integrand ends. And again, this is just a calculator issue, so the same thing we did a minute ago. And we're going to this time be doing y1 minus y2, but never write that calculator notation on your paper. And here our answer should come up to be approximately 0.410. Notice we don't have any units given in this problem, so we don't need to label anything in units. All right, and now question C, we're doing a volume of revolution. So let's take a look again. We're taking area S and we're revolving it around the line y equals -1. So you're not asked to make a diagram here, so let's still think about, though, what we've done in the past. You would have this typical Riemann rectangle, and it's going to revolve so that this will be our inner radius. So our inner radius is going to go from function g of x down to -1, and our outer radius, again, you don't have to draw this, I'm kind of messing up my diagram here. Our outer radius would go from function f of x all the way down to our axis of revolution. So this is a washer method. So you can see that they don't ask you to draw this, but the picture will be in your test booklet, not in your answer key. So you can draw in your text booklet if that helps you. All right, so our washer method, we want our pi r outer squared minus our pi r inner squared. So we have to simply remember what those are. So our volume here, if we bring our pi to the outside, so here we're going from a to 1, and again, writing down that a value once, we don't have to keep doing that. So we had our function f of x minus a -1. You can change that, of course, to a +1. That was our r outer squared minus, and our inner radius was our g of x down to -1. And I suspect you would change those double negatives to positive. And again, take your calculator, make sure you use parentheses so that you're squaring the binomials, and don't do any other work. Don't do any more work than you have to. And you should come up with, depending on the model of your calculator, again here, they would accept either one of these two answers. And you don't know the units, so we don't have to label them, but they would be cubic units. So find the intersections, and now you're going to practice a few more free response questions, but you see that you don't have to write down anything more than the setup line, and then the work you're actually doing with your calculator. So you can check the solutions to each problem as you finish them.